I've been walking plant floors for over 40 years, all over the world. And in all that time, there's one thing that's always at the center of what we do. That constant pull between safety and performance, especially with pressure equipment. So we're going to get right into this, because this is one area where you absolutely cannot afford to get it wrong.
Look, the very first thing you have to get into your head, before we even touch on codes or inspection plans, is a change in how you see these things. When you're looking at a pressure vessel, you're not just looking at a steel tank. You're looking at a device that was built for one reason: to hold a massive amount of energy in one place.
It's really easy to get complacent, isn't it? You walk past these vessels every single day, they just kind of become part of the scenery. So let's make this real. Let's put a number on the kind of risk we're actually managing here.
Yeah, you heard me right. A simple, everyday air receiver, the kind you'll find in literally any industrial plant, can be holding the same destructive power as 50 kilograms of TNT. Now, I'm not telling you this to scare you. I'm telling you this so you give it the proper respect. Respect for the forces we are responsible for, day in and day out.
So that leads us to our first main principle here: respecting that stored energy. I mean, it's the whole reason the equipment exists in the first place, but it's also its number one hazard. And our entire job, really, is to manage that duality.
The key word on this screen is potential. You got to remember that. That energy is always there, just waiting. Our job, whether you're an engineer, an inspector, an operator, our one job is to make sure that potential energy is never, ever released in an uncontrolled way. This is something I've been telling every young engineer I've ever mentored. You can't look at a vessel and see something static. It's a living, breathing thing in a way. That pressure inside is a constant force, always pushing, always testing every single weld, every nozzle, every inch of that steel. It doesn't get tired, so our vigilance can't either.
And that brings me to what I think is the most important point in this whole talk. For too long, we've been taught to think that safety and performance are opposites. That if you push for more performance, you have to sacrifice a little safety. That is an old and, frankly, a very dangerous way to look at our work.
This right here, this says it all. What is performance, really? It's the controlled release of that energy to do useful work. And what's a catastrophe? Well, it's the exact same energy, just released uncontrollably. See, they're not opposites. They're two possible outcomes from the exact same source.
That pressure isn't just there by accident. It's the engine of the whole plant. It's what makes the final product possible. So real, true performance isn't about cutting corners on safety. It's about achieving total mastery over that energy so it only ever goes where we want it to go.
Okay, so let's move on to our third big idea, which builds right on top of this. A catastrophic failure is obviously a huge loss of performance. But there's a much more common failure happening every day. It's that silent killer of efficiency: simple energy loss.
When you hear a steam leak hissing away, that's not just a safety hazard. That is pure performance and profit just vanishing into the atmosphere. When you see damaged insulation, you're looking at a constant leak in your fuel budget. It's exactly why energy management systems like the ISO 50001 standard are now a fundamental part of equipment integrity. They're connected.
So the main takeaway here is this. Next time you find a leak and you fix it, you're not just doing a safety job. You are directly making that plant more efficient and more profitable. You're a profit center, not a cost center. Don't forget that.
All right, enough theory. Let's get our boots on the ground. How do we take these ideas and apply them out on the plant floor? For me, it all comes down to a simple rule. Trust your instruments? Absolutely. But always, always verify with your own eyes and ears.
For any walkdown, I boil it down to these three basic actions. First, a thorough visual inspection. Second, checking the insulation. And third, paying close attention to your instruments. Let's break those down.
So for that first point, the visual check, here's the rookie mistake. Just looking at the big, clean shell of the vessel. The real story is almost always told at the critical load points. You need to get your eyes on the welds at the nozzles, and especially on the support legs where they meet the concrete. That's where stress loves to hide and where corrosion gets a foothold.
Now for monitoring. This is where the tech is really becoming our partner. And as we head into 2026, things like edge intelligence and continuous sensors are becoming standard. But you have to remember the distinction. The data from a sensor tells you what is happening: a pressure spike, a change in vibration. Your trained eye, your experience, that tells you why it's happening. The technology helps us, it doesn't replace us.
So let's wrap this up. I want to leave you with something practical, something you can take with you on your very next walk down. Think of this as your immediate action checklist.
First, check for corrosion and be specific. Look at the supports and welds. Second, just stop for a moment and listen. Can you hear any leaks? Steam, compressed air, they have a distinct sound. Third, look for any insulation that's damaged or missing altogether. Fourth, glance at the gauges. Do the readings make sense? Are they in the normal range? And finally, and this might be the most important one, document everything. No matter how small an issue seems, write it down. Get it in the system.
Following these steps helps you manage the vessel itself, but what happens when the process upstream goes wrong? What is that one final device that stands between a normal operation and a catastrophic overpressure event? Well, that's exactly what we're going to cover next time.